this will be a little different technical things I'll be talking about, and then by my previous speaker talked about the leaders, and then first time director, second time director. I think these are all very, very important things. So, but I'm lucky that I'm the board director of the institute, so and of course, the surrounding leaders, it will be very, very useful. I just run through my client because it's a 15 minutes time given to me. Because everybody, this is the mandate of ARCI. Of course, we need to have a vision mandate of the institute, what we have told by Professor Kanpur. And our mandate is development of high performance materials and processes for each market, and the demonstration of technologies at a pilot scale, because we need to do this really, we need to deploy the technologies, we need to have field trials carried out by for application development, and then you have to make components, and then large scale production you have to do it. Eventually for the transfer, and then another important thing is human resource development. I've been talking to the both sides from the academic institutions and then as well as the industry. And what is told is industry always feels that the student, the things coming out from the academic is not money for the industry. And at the same time, academic institute says that people are not being employed or are not being employed. So what we do is we do bridge that gap, and then we train the students so that they can be directly taken and taken employed by the industry. And many of our students who got trained at ARCI got employed in various industries. And of course, it all started with the three divisions: photometer, integrated coating, and ceramic processing. This is all with the innovation collaboration. But over a period of time, and then based on the requirement and the development what we need, and then we got expanded, horizontally spread towards the laser processing, non-oxide ceramics. Then we have a big thrust in the 2004 nanomaterials, shifted to nanomaterials, carbon materials, and then fuels and technology. And then going back to the soldier, the solar energy and automatic. And then more recently we started working on, created a separate group for the advanced materials and the batteries. Which is a big aspect what we have been doing, and also advanced photometer and magnets, rare earth magnets and the rare earth magnets what we have been doing, very exclusive focused what we have created. That's what I created it after I become director. So what exactly in a nutshell what we do is, we always see on one hand, fundamental R&D and then to do it an invention, but then it has to be deployed, then it has to go to the innovation. But it has to cross the barrier of that. And then many of the developments what we have done in the lab will not be deployed. And then the world average also, if you're looking at patents which are commercialized, only 2%, 2 to 3%, that's the percentage of the patents which are commercialized. So what we do is we see that our inventions cross through the valley of death, and then eventually will be deployed by the industry. That's what we do precisely in a system. And of course, we have been doing it for various thrust areas, including various advanced manufacturing, aerospace, power, alternate energy, architectural, electronics, water, textile, oil and gas. So all those areas we have been developing technologies and then deploying it. And over a period of time, we have done 47 technologies we have transferred, and then worked and then more than 250 technological solutions we provided to the industry. So when I say technologies means, we have IP which we have licensed with, patents licensed with, and then whereas solutions means, it's only the know-how transfer, so there is no patent IP for an industry. That's kind of an incremental innovation or substitution of one of the unit operations in an industry. And that's what we have been, we have done that. And of course, when I come back to that, this is what we have to going to looking at, the technology development priorities in the next decade. This is very, very important. And we're looking at the energy. So that means you need to do the materials for the energy generation, energy storage, and then energy conversion. And of course, zero CO2 emissions. We have been told many speakers yesterday were talking about sustainability and then zero CO2, net zero, zero complete elimination of CO2. So that's what the technologies go to capture and conversion. Then you need to have an alternate fuels, non-fossil fuels. We need to develop and then use it. Then of course, other thing is critical metals and minerals. We need to have all the new, either it can be a magnets or it can be new high strength, alloys, high temperature materials. We need it for either for defense or for displays or for power grid applications. You need to have that. Then we also need because as such India doesn't have much of the critical metals and minerals, we have been importing them. Then recycling to be the technology which has been developed completely to recover all the materials. And of course, another disruptive technology which has come as a metal additive manufacturing. So there is no bound. So your imagination is your thing. Then you convert into a solid state drawing and then feed it into the machine. Then you can print whatever the shape, whatever the size, what we need. Then of course, other thing is precision controls. That means you need to have one of this to increase the efficiency. That means to reduce the friction. So you need lubricants, and then you also need sensors for autonomous vehicles, and then even for robots and another thing, sensors is another one. Then the coatings for any material to withstand to do that, whether it can be wear resistance or corrosion resistance or for the beautification. So those kind of coatings you need that. Then high specific strength components. You need to have a lightweight and then high strength so that your weight of your component or weight of your vehicle or anything can be low. So another thing is semiconductors. Then biomedical, we are talking about many of these plants are being imported, and then more recently, which is developed a corollary study by our sister organization, Institute, where a stunt was made by them, and then we have given a titanium nitride coating to that. So it's a kind of a development between ARCI and Srikindrath. And then we are also working on biodegradable implants. So that's another new area. And another most important thing, we have been talking about technology and other things, but then most of the equipment is not being manufactured. So whatever may be some simple equipment, we still import them. So the capability to manufacture that kind of an equipment and has to be done. Then of course, last but not the least, of course, AI and ML. So that's which are all the drivers, technology drivers. So you can, all the students, you can orient yourselves and then fit into any kinds of these categories to build your career. And of course, now I will quickly go through that in these areas, how we have gone through the technologies, how we have developed, and then how we have crossed the barrier of death. So we started with the one of the everybody knows now, government has got, and then we are also looking at as an electric vehicles, but then the batteries and all are imported, so we don't have the technology to make the electrode materials. So one of the cathode materials, LFP, which is made, started with the flame pyrolysis, but everything was well. But the question was, when it happened, the cost was very high, so no industry was able to take it. Then we moved to the solid state process, we have done it, and then this is what we got it, all the properties which is comparable with the imported material. But we need to produce in a large batches, so we entered into a public-private partnership with the industry, and we have developed in a large batches, and then eventually we transferred this technology to 3 companies. And one of the companies, you can see that global exclusive, non-exclusive, and then we have also given them an incubation facility here, and it was done under our former director, Dr. Tata Narasimha, and then I am also part of it. We both work together, and then we have done it. And this is being incubated, and then we are setting up 1,000 tons per annum plant in Hyderabad. That's the one, and then this is what we have moved it from the lab scale. So then a few grams to the kgs, and then tens of kgs, and eventually to the hundreds of kgs, and then we're looking at tons per annum capacity. That's what is going on by the industry. This is our journey of a particular technology. Then we also said that during this process, until unless if you know the material, just material doesn't, it's very difficult to push it in the market. But then we need to make a component, so we need to have facilities to be established all those batteries. And then we also moved on to the next generation batteries, sodium ion batteries, and NMP, sodium vanadium phosphate, and we have done it at 1 kg level, and we have the properties are very good, and then 3-4 industries we are interacting with them. So we have to demonstrate this technology, and then eventually it will also be transferred for the next generation batteries. Then other electrode material for the sodium-ion battery, similarly for the hot carbon. So what we have done is from an industrial waste, and then we have converted it into the non-carbon. And another important thing is the thermal management of the battery. So if you don't manage it, you might have seen that there are fire accidents of the battery. So what we have done is a carbon PCM composite material, which is done, and then we are testing with the industry. So this is another know-how transfer technology for the fabrication of the batteries. We are transferred to an ensure. So they have established based on know-how 2 megawatt hour plant, prototype plant for making 30 ampere hour wholesale facility near Bangalore. And this is all the facilities. It's all based on our input is being established by the industry. Then another thing is our PEM fuel cell is being demonstrated at the cell phone tower in Pune, airtel tower at Pune, to powering a cell phone tower, uninterrupted power supply that's being demonstrated for an airtel tower. And another thing is yesterday, Mr. JDR stock also talking about is a hydrogen production. So we are doing that as a methanol reformer to produce hydrogen. And we are in the final stages of the talk for the technology transfer this hydrogen generation to methanol reformer. So this is what, and then this is integrated to the solar PV plant and then demonstrated. So you can use that energy and then convert that methanol into an hydrogen. And the biggest, the takeaway is it takes only 18 units of energy per generation of 1 kg of hydrogen, unlike 40 to 50 units of energy needed for an alkaline electrolyzer. So another thing is we are looking at alkaline electrolyzer. You might be thinking that it's a well established and what is new, but traditionally all alkaline electrolyzers use nickel or nickel foam as electrodes, and then they are expensive, and most of the nickel is being imported. So what we have done is a normal SS304 stainless steel, and then given a corrosion resistance coating, and that is giving very good performance and cheaper. And we are building around 1 kilowatt stack. With this all this design, and then it is all everything is designed by us, the SolidWorks, and then every component is identified and fabricated. We have assembled this electrolyzer. And we have also got a PEM electrolyzer because we need to have a comparison with what is the state-of-the-art facilities, and then this will be connected to our solar grid, and then generate hydrogen, and then this hydrogen will be used to convert CO2 into any other organic compound, not as a fuel. That's one. Then we are also working on moving from the rare earth-free magnets to the rare earth magnets to the rare earth-free magnets. So the ferrites is another one. So asynchronous motors is being developed, and then this is also a demonstration, technology demonstration is being started out at ARCI magnets place. And this is another technology we have developed for the stranded unions for the DRDO. And you can see that LCT, lanthanum, helium, titanium powders were done. And then given that HVF coating, and this is all test fired. And other is also detonation spray coating is given for the big pump for the nuclear reactors. And this is what it does, that both ID coating, we will take another minute, and then gives it. Then we are also given the coatings, pulse electrode deposition and the gun barrel inside for giving you a wear resistance coatings. It's also being done. Then for an ABP multinationals, we are working on these contactors for giving, because when you switch on and off, there is spark generation, and then you can see that there is a wearing out of those components. So we give a hard coating, and then it is demonstrated, and we are in the process of transferring this technology to ABP. And we have also have a prestigious project from the space and the defense for the low expansion glass ceramics, and we have established this facility, and we have been doing it. All those 90 kg of the ceramic powder is melted and then casted into a block, and then it's cut into different pieces of different sizes, and then polished. It can be used in various gyros and then other applications. And we are doing it in a repeatability, technology, production repeatability, we are doing it. Then other project what we got is a solid oxide fuel cells with the association with the CSIR. We have established a pilot scale facility to produce all those motors, electrolyte, and then interconnects also. We have been developing it. We have made this anode dead casting, electrolyte, everything we have done. And then other is we have done laser assisted machining. This is going to be GE, which runs at around 35 to 40,000 RPM. And then you need to have that kind of a laser processing so that the lubricant, each one will act as a pool for a lubricant so that there will not be any friction generated and then there will not be any wear. And this is all supplied to the GE. Yeah. So this is coming back to my last slide. I mean, what I'm trying to say is, when it comes to the technology, it's a multidisciplinary. From a fundamental science to the engineering to the marketing, and then how do we do it? So we always, what we do is in ARCI, we create a platform. So we bring everyone together to make our technology, and so that everybody can win, and then India can become a basic part of my COVID policy. Thank you very much.